You see that?
Oh, there it is.
The laser beam is made up of tiny particles of light called photons. Photons behave similarly to electrons, but because we can actually see photons as light, they're ideal for this experiment. The laser beam is filtered, so single photons fire off one at a time. The individual particles then arrive at a plastic barrier with two narrow slits. On the other side is a sensitive camera to show where the photons end up.
What do you expect? You expect we'll hit two spots here, like that, or you expect the photon will go all over the map? What do you expect? We have two slits here.
The choices are all over the map, or just those two spots?
Just two spots, yeah.
Just the two spots?
Exactly. Mark is using his common sense. Imagine this experiment was blown up to a much larger scale, so that the particles are tennis balls, and a machine is firing the tennis balls at a barrier with two gaps in it. Of course you'd expect to find the balls hitting the back wall in two places in line with the two slits. But when our experiment is done with individual photons from the laser, something very different happens.
Okay, you see a screen up there?
Yep.
That's what we see from the camera. See those individual flashes?
Oh, yeah.
Those are the photons.
Each flash of light is actually an individual photon hitting the back wall. They appear to be landing all over the place. But watch over time and a pattern emerges.
Can you see somewhere in the middle of the screen?
It looks like a smudge.
Yeah, it looks like a smudge.
Yeah.
Those are the photon, where the photon hits. But it's not two, as we would expect. Is that weird?
Yeah, so why is that?
That's right, why is that?
Instead of the two bands that you'd expect, a series of smudges appears. It turns out that some photons land in a place on the back wall that would be physically impossible if they had traveled straight through just one of the slits. So on the quantum level, particles like photons don't always act like tennis balls. Instead, the pattern of photons matches what you'd get if you sent waves of water through the slits. It looks as if, while it's traveling, each photon spreads out into a wave, passes through both slits, then interferes with itself on the way to the back wall, where once again it acts like a particle, showing up in just one spot. Could this mean that as it travels, the photon goes through both slits? That it's in two places at once?
Now you're blowing my mind.
Good, that's our job to do, to blow people's minds, so make you think, right?
Whew, my brain hurts.
Okay.
I wish I was back home playing my guitar.
And it's not just photons that behave like this. The double-slit experiment has been replicated with electrons and with atoms. So you might wonder, if we are made up of atoms, and if atoms could be in two places at the same time, why couldn't we?